The last thing we're going to talk about this week is how to set up what is called a motion information table. So this is just a table. It's a way to organize the information we're given in a problem in a way that kind of makes it clear to see what we're trying to do. And I'll tell you that I personally don't draw motion diagrams that often because I don't think they're that helpful for me. But I always draw motion information tables because those are super, super helpful for me. So the point of it is to identify key events. We're going to talk a lot this semester about what an event is and the quantities. The quantities are the things that we measure, the position, the velocity, acceleration, things like that. So let's look at a sample problem. You drop a soccer ball off a 180-meter high cliff. How long does it take to hit the water? Okay, so first, what I like to often start with is by drawing a picture. So I'm going to draw a picture. I'm going to have my cliff, and I also am showing the ball when it's up here and the ball when it's down here. The reason I put the ball in both places is because I know something about the ball when it's up here. I know its position. And I know something about the ball when it's down here. I also know its position because I know that it's 180 meters higher here. Maybe I set this to be y equals 0, then this would be y equals 180 meters. So because I know something about the ball, about its certain quantities like position up here, I draw it here because I want to know what's the position, what's the velocity, what's the acceleration when it's here, what's the position, what's the velocity when it's here. So this is just a helpful picture. We're going to identify the important variables, okay? And right now we haven't talked too much about what variables we care about, but as we start to use our kinematic equations to solve these types of problems, you'll get really comfortable with what those variables are. For now, I'm going to say the main variables you want to know about are time, position, velocity, and acceleration. Now you don't know this yet, but the whole time this ball is falling, it has one single value of acceleration. But up here, the ball is up here at a certain time. I'll call that t0. The ball has a certain position here. I'm going to call that y0. And the ball has a certain velocity when it's dropped. I'm going to call that v0. All these variables change as the ball is falling, falling, falling. And then down here, it falls at a certain different time. I'll call it t1. y1 is the position it has when it's at the bottom. v1 is the velocity it has when it's at the bottom. So by setting this all up, we're getting a really good idea of what variables maybe are told to us and what variables they're asking for. So we're going to put all this in a table. And in the table, you're going to organize it by events. Okay, so now we're going to start to talk about what is an event. An event is like a moment in time when something happens or when you want to know the values of something. So I would say here we have two events. One event is when the ball is dropped, and one event is when the ball hits the water. Okay? Or that should be water, sorry. Let's fix that. There we go. So the ball is dropped is one event and the ball hits the water is another event. Okay, so I'm going to make a table where I have two columns. This column is for what I'm going to call event 0. Remember, physicists like to start numbering at the number 0. So this is the first event is number 0. The second event is number 1. Just deal with it. And then this column represents all the variables that go with event 1. So I'm going to put my time in this first row, then my y position and my velocity. And then this is going to be the time t1. That's what time does it hit the water. What's the y position when it hits the water? What's the velocity when it hits the water? In the middle, I have delta t. How much time is elapsed? That's just t1 minus t0. That's going to go here. Delta y, that is my displacement. My y displacement. My y1 minus y0. That value would go here. We don't really care about delta v, that doesn't show up in our equations, but I'm going to put a little spot here for my acceleration because we can think that our acceleration is a thing that brings us from this event. We accelerate and then we get to this event. Okay, so this is just an empty table, and this is pretty much how it's always going to look when you first just set it up. You have your event 0, time, position, velocity. Event 1, time, position, velocity. Sorry. And then this is what's the change in time, the change in position, and your acceleration. Okay, so then the next step would be to look at your problem and figure out and fill in as many of these values as you possibly can and identify the thing you're looking for. So here I filled in You can always start at t equals 0. I put my y equals 0 at the water, and so my y0 value is 180 meters. And because it's at the ball is dropped, we're going to learn that when something is dropped, that initial velocity is 0. I also know that when it hits the water, the y position will be 0. Okay, so I can, because I knew y0 and y1, I can calculate delta y as negative 180 meters. We're going to learn next week that when an object is falling in the air, the acceleration is negative 9.8 meters per second squared. We will learn that next week. Okay, so I filled in as many things as I can, and then I've circled the variables that they asked me for. They said, how long does it take? So they're asking for T1, or in this case, because T0 is 0, it could also be that they're asking for delta T. So this is going to help me because when I look at all the equations I have to possibly solve this, I'm going to look for an equation that has delta T in it because that's going to be the variable I'm going to solve for. Now, one thing real quick that I'll mention a lot, you might think, oh, isn't V1 0? Because when it hits the water, the velocity is going to be 0. Well, we're going to say this is like right before it hits the water. This is the velocity right before it hits the water. It's 0 after it hits the water and the water exerts a huge force on it and it has this huge acceleration due to that force. This is not 0. It's 0 after it lands. So this is kind of like the instant before it hits the water. That's what this velocity here represents. And we'll mention that and talk about that a lot more coming up. So let's take time to work through another example. Okay, so here is a sample problem. We're not going to solve it. We're just going to set up a motion information table. Mainly what I want you to do is try to identify the main variables. Think about what events we have, and I want you to make a motion information table for it. So press pause, take as long as you need to work through this, and then press play and we'll go through it together. Okay, so the events that I identify was I'm calling event 0 when the light turns yellow because that's when something happens. Something happens when the light turns yellow. And then something happens when we exit the intersection. These are the two endpoints that I kind of care about. I put my origin at the start of the intersection. So the it's you in this case, you're the one doing it. You are at the position x equals 0 when the light turns yellow, and you make it through. So you accelerate for 20 meters to make it through. So this is where you are when you exit the intersection. You're at the position x equals 20 meters. We know right when that light turns yellow, you have been going 12 meters per second. And when you exit the intersection, you're going 18 meters per second. So based on what I know, I've already calculated that delta x is 20 meters. That's my displacement. And this doesn't even have a question. It's not even asking you anything. Maybe they could ask you, how long did it take you to get through the intersection? Or maybe they would ask you, what was your acceleration, right? We know you're accelerating because your velocity is changing from 12 to 18. So maybe they might say, what's your acceleration? And this would be the thing you solve for. Or they could say, how long does it take you? And this would be the same thing you solve for. The point is, right now, we're just filling out this table so that we'll be ready for the next step, which is looking at all the equations we're going to learn next week and choosing which equation to use to solve for whichever variable they're asking us for. But that's all going to come next week.